Hello, and welcome to another episode of Technical Math Applications. My name is Lee, and I'm a math instructor here at Bellingham Technical College in Bellingham, Washington. Today, we're going to be visiting with Professor Jacen to learn a little bit more about precision machining and the math used in this high-tech career. The machining program trains for jobs in aerospace, manufacturing, fabricating, and CNC custom shops. So from Campus Center, we're going to take a right and head to the B building to access the labs and the classrooms. The AAS associate degree takes 6 quarters of classes. So throughout your time at BTC, you'll learn how to read blueprints and program CNC machines. You'll also learn how to use machine tools such as lathes, drill presses, and milling machines. So let's stop in and see what we can find out. Hi everyone, I'm here with Jacen Johnson, who is a machining professor at BTC and an expert in the field. Jacen, how long have you been at BTC for?
By the time you see this video, 7 years.
All right. Could you tell us a little bit about what the machining program at BTC entails?
Yes. So machining at BTC is a process of learning how to remove material from a given stock to create a desired shape. What does that entail? That means you will be operating machines such as a manual mill and a manual lathe, and you will have given a print. A print is a drawing of a part with dimensions upon it. So you will take a rough piece of material and create a finished piece of material to the dimensions on the print. Machining is that process. It is the removal of material to create a shape. I personally love operating a lathe. The lathe is my favorite machine. It's the one that goes roundy, so it makes round parts. I enjoy it. It's very interactive. You get to use both of your hands at the same time. You're in very close proximity to the material as it's turning, upwards of 2,000 RPM, which if you've never been right next to something that's running at 2,000 RPM, that's revolutions per minute, it can be a little frightening at first. So part of being a machinist is building up a tolerance, an emotional tolerance to objects moving very fast in front of your face, and you being the one in control of them. The other machine that we predominantly operate in the first 2 quarters is the manual mill. In the manual mill, the tool is the thing that goes roundy. So you are holding the object that you're cutting in a vise on a table, and you move that object up against the cutting tool to create the shape. And
sounds like you have to be pretty accurate with your calculations there.
Very, very accurate. We typically deal in tolerance of plus or minus 5/1000ths of an inch. So we speak differently than the rest of the world when it comes to decimals. So 5/1000ths of an inch for a machinist is 0.005. I know no one else calls it that because they don't speak in thousandths of an inch, but we do.
Wow.
So let's put it this way. The thickness of your hair is about 3 thou, 0.003. Most of our tolerances are within that range.
Wow.
Yeah.
So how is math used in other ways around the shop or in your classes?
Well, for every machine that you're operating, you have to come up with a RPM, a speed. And each one of those speeds is based on the material you're cutting and the tools you're using to cut. So you have to calculate that speed for every tool or every part that you're cutting based on every material that you're going to use. Aluminum cuts at a different rate than steel.
Mm-hmm. Yeah, a lot of technical calculations that you have to do. Could you give us an example of what maybe a first-year student would see a problem?
Yeah, so the number one problem you will have to solve every day is 3.82 times the SFM divided by the diameter of the thing that goes roundy. So, an example, if I were to put a 1-inch piece of stock in a lathe, then that material is 1018 steel. I would calculate the RPM as 3.82 times 100 SFM, because I know that the surface foot for steel is 100. I let some really smart people calculate that, because that has to do with the construction of the materials themselves and how they break apart from one another depending on what's cutting them. And that's some way up there upper level math that I am not qualified for. I like to say that's above my pay grade. So I do 3.82 times 100, and then I'm going to divide it by the diameter of the material, which is?
What is my diameter? I got a 1 inch right now.
1 inch.
Yeah.
So 382
I'll
RPM.
go do it. I'm going to go do that math. Okay, I've got a 3.82, my SFM divided by my diameter. Okay, I'm going to go do this technical application and see what I find out.
Perfect.
Okay, thank you so much. I really appreciate you joining me on Zoom today.
You're very welcome. Anytime.
So it sounds like this is a pretty essential formula to get right. I was really interested in where that 3.82 came from, so I did some research. If you take the surface speed and you divide it by the circumference, that equals your RPM. And the circumference of the tool is just pi times diameter. The 3.82 is essentially 12 divided by pi. Pi, 3.14. So the 12 is to convert from feet to inches, and this becomes the constant in the formula. The surface speed, or the SFM, comes from a chart based on the material you are cutting and the tool you're cutting with. So Jacen asked us to calculate the RPM using a 1-inch piece of stock, which will have an SFM of 100. Multiply across and divide by your diameter, and we've got 382 revs per minute. So let's try another example, but this time, since thousandths are ultimately important in machining, let's try a diameter of 1 and 125 thousandths inches and change the material to be 200 SFM. So pause now and do the math. Don't jump for your calculator just yet. Try to remember the steps to multiplication and division, including decimals. Okay, we're back, and I bet you did great. So 3.82 times 200, this multiplication involving decimals. Which number goes on top? Where do we start? Here's a shortcut. If it involves zeros, you can slide them to the end and then drop them below. Then multiply through by 2. At the end, you need to transfer your decimals to your answer. So count the number of decimal places in the problem and transfer them to your answer. We have 1, 2. Now, let's divide by 1.125. To divide by a decimal, you must first get rid of the decimal in the divisor. We will move the decimal 3 spaces to the right in the divisor and in the dividend. So this is only the tip of the iceberg when it comes to machining formulas. Take a look. Square roots, exponents. Also, trig is a really helpful tool to find angle measures when you're dealing in circular environments. And don't forget about the steps of problem solving. These are pretty universal. Understanding the problem, making a plan, working through it, and checking the accuracy of your work or revising is an essential process. That was a quick look into the machining program. I'd say it's pretty crucial to brush up on your math and problem-solving skills before jumping in. At BTC, you'll be challenged to read and interpret technical blueprints to produce highly precise products using the latest technology and machinery. Good luck! Be safe, BTC!